Small mammals generally tend to have a higher metabolic rate than larger species, and so can often run into difficulties maintaining their energy balance due to high heat loss. According to a number of literary sources, many small mammals have adapted a coping mechanism to allow them to limit heat loss by adjusting their activity patterns in relation to temperature change. That is, as temperature increases, so does activity levels. In this study, I aimed to determine if increasing ambient temperature had any effect on the activity pattern of a small rodent species found in Madagascar known as the Tenala tufted-tailed rat. As a majority of the information published surrounding this theory is in regards to prey species, I also wanted to determine if this relationship could be seen in a major Malagasy predator, and so activity patterns of the fossa were also investigated. In this study, I assessed a series of camera trap entries from the Team Data Network from the Ranamafana National Park in Madagascar. The trapping took place from August to January over a period of 4 years, from 2010 to 2014. I narrowed the data down to the temperature range, which fell between 11 degrees Celsius and 21 degrees Celsius from this period of time, as well as the number of animals present of each species. I then used the statistics program RStudio to analyse this data. I decided to use a correlation to analyse the data as it assesses the strength of the linear relationship between two quantitative variables. The primary output of a correlation is given by the correlation coefficient, which is expressed as R, where R is ranges from -1 to 1. When R equals 0, there's no linear relationship. When it's larger than 0, one variable increases as the other increases, and when it's smaller than 0, one variable decreases as the other decreases. In this case, our findings were quite inconclusive. Both animals returned a correlation coefficient very close to 0. This indicated that although there was a small correlation, it was a relatively weak correlation. This was further emphasised by the larger p-values given for each animal's correlation as well, indicating that the results were also statistically quite insignificant. This weak correlation could also be seen when graphing out the data, as both animals' numbers could generally be seen to be increasing as temperatures increased to 15 to 17 degrees Celsius, and then all of a sudden they just dropped off after reaching that temperature. This could have been due to a gold mining disturbance happening in the area at the time, disrupting activity, or simply due to the relatively small sample size. It was interesting to note that when comparing the activity times of the two animals in relation to each other, it could be seen that there was some association between rat and fossa activity. This was most likely due to a predator-prey relationship, where the fossa was more active at times that its prey was active. So although literature suggests that an increase in ambient temperature should also cause an increase in an animal's activity, in particular with small mammals, the results gained from this study showed only a very weak relationship between either animal's activity pattern and an increase in ambient temperature.